Okay, here's our second lesson from 2.2. Okay, so we're going to work backwards today instead of having a value and using norm CDF to find the area under the curve. We're going to be given the area under the curve. Still need to draw the normal distribution. You're going to use technology to get that. There's two ways to do that. We'll show you both ways. And be sure to answer the question was asked. That's actually always true. Okay, so here's a problem. The heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4. Okay, so go ahead and just draw your curve. Just draw your normal distribution. And it says 75% of 3-year-olds are taller than what weight. So we're trying to figure out exactly, and I think we're just kind of guesstimating when you draw that between 90.5 and 94.5. We know 50% is at 94.5. It's somewhere to the left of that. I'm not worried about guessing it too accurately, although that is about right as far as, because the first standard deviation is 68%, so that means 34% is between 90.5 and 94.5. So if you add 50% and 34%, that's 84% is to the right of 90.5. If this is approximately normal, so 75% has to be in that range. But it's definitely to the left of the median. That's the big key there. Okay, when you sketch it out, just make sure it's to the left of the median, draw your line. And we're just kind of guessing that. It just gives us kind of something to go from. So in this case, one way is to kind of work it backwards. So here's what I mean by that. So if you're working backwards, you know the percentage, you're trying to figure out, say, the z-score. Let's try to figure out the z-score. So to do that, you're going to go Menu, Statistics, I think it's in Distributions, and it's called Inverse Norm. There it is, right below Norm CDF. So this is kind of working Norm CDF backwards. Given the area first, what do? So you have to put the area, and the area in this command is always to the left of the value you're looking for. So we're going for the x value. The area to the left of that is 25%. So I'm going to say 0.25. Because I'm going to try to find the z-score here, I'm just going to leave it as 0 and 1. Just say OK. So it tells me the z-score is negative 0.67. That looks about right, right? Negative 1 standard deviation would be 90.5. 0 is 94.5. That's the mean there. So that looks about right. So if we set up an equation, let's use the solve command. So to solve this rather than do this by hand. So we're going to go solve. So the equation would be, I guess it's control divide. So let's see. Got the value we don't know minus the mean of 94.5 over the standard deviation, which I think was 4. Equals the z-score, which is that negative point whatever number. With the solve command, you have to put comma x to solve for the variable, and it will solve it for you. It gets that for the answer. So I chose not to round my off, so that's a very accurate answer. Some people might round that to negative 0.675, maybe 3 decimals or something. We'd probably accept that answer as well, but just nicer to get the actual number. Now, you don't have to do all that. That's called standardizing it. But you can actually just go to Menu, 6, 5, and then 3, again, as inverse norm. And this time, I'm going to say the same 0.25. But now I'm going to actually just choose to put in the mean and standard deviation for this particular data, 94.5. And then the standard deviation, I think, was 4. And it gives you the answer right away. It doesn't tell you the z-value, and sometimes the question might ask about the z-value, so it is good to know the other way as well, but if you're just trying to get the answer, it's a little bit faster there. So just as long as you know what you're looking for here. So again, use the technology to get it, and you can do it 2 different ways. Be sure to answer the question that was asked. We haven't answered it. Using that, about 75% of 3-year-old girls are taller than 91.8. Again, the 91.8 came from 91.802, right? Approximately that. Okay, let's do another problem. Just make sure you're getting it. So here, after accelerating 20 seconds, a DeLorean sports car I've actually ridden in one before, has a wide range of speeds that can achieve depending on traction. The distribution of speed follows an approximately normal distribution with a mean of 80 and a standard deviation of 7.7. Okay, so Marty wants the next acceleration run to be the fastest 15% of all possible speeds. How fast will the car have to go? Okay. So we just kind of drew 15%. Again, I'm not so concerned in this stage where you draw that. It needs to be to the right of the mean because that's median, that's 50% there. To the right of 80, as long as you draw a line, just helps to picture it. So if you see there's 15%, the top 15% is what we want. So the bottom, the rest would be 85% because it has to add up to 100. Because remember, area underneath the density curve has to add up to 1. So 100% it has to add up to. So you do 1 minus 0.15 to get 0.85. Or just think about it. It adds up to 100%. Okay, so let's do this in the calculator, right? So let's see. So here we go. We go to the command menu 653. And we get area is 0.85 because it always goes to the left with this command. We're just keeping a z-score form and say, okay, we know the z-score is 1.03. That looks about right where they drew that, by the way. So we're going to use the solve command, solve, and we're going to go control divide and x minus the mean of 80 over the standard deviation of 7.7. equals, I'm just going to grab that number, grabs the full number, by the way, or at least the actual number from the calculator memory there, comma x, you have to put comma x to solve. It'll solve it for you, or of course you could just let the calculator do all the work for you. Menu 653, and area is 0.85, and then you put in the 80 there for the mean, standard deviation of 7.7, and it should do all the work and give you the answer right away. So 87.985. Again, make sure to answer the question and how fast will the car have to go. So in this case, at least 88, basically, would be the speed. 88 miles per hour would be the speed there. Okay, great job. That's the end of that quick lesson there. Thanks.